This is David Vizard here, and you are watching PowerTec 10. Let me remind you that this is the channel where you get the real tech. That is, stuff in detail. The subject for this, episode 97, getting close to 100 now, is stealth. Now, that can mean quite a few things, so let me show you this engine here. This is the opposite end of the scale of stealth. One look at this and you know that there probably isn't a stock component on there. And you'd pretty much be right. Other than the block, it's got nothing that Ford made. Now, I'm going to be doing a story on this. This is my how shall I say, it's something of a tribute to DSS, because this engine was done mostly while I was recuperating from my brain surgery. So I have to thank Tom at DSS and Terry at Terry Walters Engines for picking up the reins for me and doing this. The target was, it was a very obvious, fancy looking, high output street motor to run on pump gas. Now, how much horsepower did it make? Our target was 710 horsepower and 600 foot-pounds for this 87 octane fueled engine. That was our target. How much did it actually make? 707 horsepower and 598 foot-pounds. Pretty close. Not bad for 427 inches for the street on pump gas. But, like I said, that's the opposite end of the scale. Now let's consider an engine which, how shall I say, looks like it's ready for the junkyard, but it's in disguise. It looks stock and untidy on the outside, but underneath it's got a lot of horsepower. All the work has gone into the inside of the engine so that it doesn't show on the outside. So let's start on the concept of doing that and all the things you can do. First, don't make the block look fancy on the outside. Just clean it up and maybe paint it with some semi-transparent paint so that any imperfections on there, they're still obvious there. Doesn't look like it's been touched, but it'll be clean. Cylinder heads, gotta be iron ones. You need to refer to my, oh, we're doing this on a Chevrolet engine, by the way. You need to refer to my porting deal on a 186 head casting, which can be done on other similar closed chamber castings. And that means you'll install a set of heads that make as good and more often better power than aluminum aftermarket heads, right? On the outside, they can look totally stock. Compression ratio, that needs to go up quite a bit, and you need to run on good gas. Compression ratio is, how shall I say, the poor man's best friend if it's only a matter of showing how fast you can go with what looks like a piece of junk. Things like water pumps and pulleys and things like this, don't make them look fancy, just clean them up and leave them all scratched and that. Thermostat housing, do not use a new one, use a corroded one. Carburetor will be underneath a filter, an air filter, right? And the carburetor needs to be clean, tidy, doesn't need to be fancy. And it needs to be a stock looking carburetor, not a performance one. So either we would use a stock Quadrajet, suitably modified, or, and this is a carburetor which I think has been shortchanged, the replacement that Holly did for the quadrajet, which was the oh, I can't think of what it was called now, but it had 2 big barrels and 2 small barrels. That came over as a non-performance carburetor, but you can get surprisingly good results from that, and it doesn't look like a performance carburetor. Make sure everything on the inside is good, but the outside, not so much. Distributor, a crummy looking HEI with the right internals in it. Needs to have a good gear, good bearings, and a good module. Now, pretty much, oh, and headers. Now, there's a lot to be had from having cast iron headers that are ported. I'll talk about that down the road, but for now, what we're going to deal with is the intake manifold. And I'm going to show you some, how shall I say, rather unconventional manifold mods. This is something I did, 30 years ago for, I think, an update on one of my performance books. How to modify your small block Chevy on a budget. Right, I don't think the manifold is in there, but there's a lot of stuff that it tells you to do with stock parts. So if you don't have that book, here's what it looks like on the cover, and you can get it from Amazon.com. It turns out that the secret of making this stock intake manifold work lies mostly in the plenum and the use of about a 1/2 inch, maybe 3/4 inch spacer. Of course, that doesn't mean that you shouldn't spend some time matching the manifold up. That is the manifold junction with the cylinder head. And the other thing is attempting to round off the corners in the intake itself, where it turns from the plenum into the runners. Now, a point that I can bring up here is that many years ago, the guy with the nickname of the Cast Iron Racer was modifying manifolds for those classes which were supposed to run a stock manifold. And this was a stealth deal. What he did was bore lots of holes in the bottom of the manifold, take the piece out, the slug out, go in, port it, and then put the piece back in and weld it in and cover it all up so it looks like it hadn't been done. And those manifolds worked well, but they could be improved on. So, if you want to do just the plenum mods and the mods to match the manifold runners to the cylinder head ports, then here's what you need to do. First, let's look at a stock intake manifold. Like all projects involving airflow, things started right here on the flow bench. What you're looking at here is the stock plenum to carburetor interface. If you look carefully, you'll see a couple of pieces of cotton going into the lower right hand side carburetor bore. This is where I started, and that was to trace where the air was going. This was the very first move I made, and I had not yet put on an entry to simulate the exit of the carburetor. So excuse my oversight there, but let's move on to the next shot. Let me start by saying it's pretty much common wisdom that a spacer between the carburetor and the manifold, when it's a two-plane manifold, will help the induction system in as much as each cylinder has all 4 barrels to draw from rather than just 2. And this is what I'm aiming for here. The first thing I did was to cut out the 2 areas that I'm indicating with the arrows. Also, you will be able to see that I've radiused off, or started to radius off, the area indicated by the red arrow. As in the slide I've just shown, the other corners, or plenum to runner corners, need to be radiused off. What you're seeing here on the deep plenum, that's the one on the left in this photo, is a relatively small radius on that corner. That's because I haven't got to it yet. The reason that it can't be too generous is that it will break into the runner adjacent to it, or whatever else may be there. On the other hand, the radius on the right hand upper plenum can be as large as the casting will allow from the casting face. In fact, if we're going to put a spacer on, we can actually put the spacer on and enlarge the corner using the spacer as, how shall I say, additional material to do that radius. The bigger the radius we can get here, the better. Now here is where you will start to see some unorthodox moves. First, the spacer, not so unorthodox in itself, but note how it's been cut to the outer form of the manifold. Those of you who've got an eagle eye might spot that the divider between them is starting to take on a form which is rather different from usual. Inasmuch as the edges are being rounded off. Now, these edges weren't rounded off at random. You'll notice that the width across that divider varies considerably from one side or from the front to the back of the plenum. These were rounded off relevant to the information conveyed by nothing more sophisticated than a piece of cotton and an observant eye. The key to the success of producing output is very much linked to the fact that we need to remove the minimum amount of material from the plenum area to get the best flow that is possible. Ultimately, the flow's limited by the runners and the entrance into the runners. But we can make it so it's independent of the carburetor flow. So if the carburetor is flowing a healthy 780 CFM, that is what this plenum is seeing. This is the form of the divider, more or less finished. Why did it end up at such a funny shape? Well, that's all from the cotton testing on the flow bench. Anyway, the thing at this point is to clean up the runners. Now, you can do this either with extensive sandblasting down each runner, or dip the whole manifold in some swimming pool acid will do the job. From here, I put this on a 350. In fact, I put it on several, but let me quote the one that I've got to mind here. It's a 350 with about a 10.5 to 1 compression, cam about 280 degrees, flat tappet, and we used that as a guinea pig to test the manifold itself versus a stock one versus a Edelbrock Performer RPM one versus this one with both a spacer in addition to the one we blended to it, and that's about it. So let's take a look at that. Earlier on I mentioned that I didn't think that this result diagram was in my Holley carburetor book. It is, along with a ton of other great stuff. just refer to page 58 and you will get there. Now, what this shows is the before and after flow figures, and the before figures are actually those written in the runner, right by the end of each runner. The after figures are those on the yellow background adjacent to each runner. You can see that in some instances we've got a huge increase in flow. For instance, on the top left-hand runner went from 197 to 285, and remember, most of that is due to work in the plenum, getting that air into that runner. But a similar amount of flow increase has been seen elsewhere, like 190 to 282 on the bottom but one right-hand side runner. Anyway, let's take a look at that and see how it fares in terms of horsepower. Testing just the intake modifications, what we see here is the result of such. The black line is the stock manifold, the green line is the modified one. And let me remind you again, that's without the spacer involved. Now, what we see is about a 11 horsepower increase and about a 12 foot-pound increase. But the increase starts right from square one, even though it's only a low amount of increase at low RPM. Now, if you watch that fade through carefully, you'll see that adding the spacer contributed to quite a bit more output, both in torque and horsepower. At this point in time, we've gone up from 343 horsepower to 369, an increase of 26 horsepower. As far as torque goes, we have gone from 377 to 398. That is pretty stout in terms of torque for a 10.5 to 1 350 with so little done to it. At this point, we stepped out of the stealth mode and just tried something else. What was done for this curve, and you can see the gain from the fade out from the previous one, is we made up what has now become known as a super sucker spacer. That is a spacer where you start off with the same pattern as the carburetor and end up with the same pattern shape as the plenum. Well, what we did here was put two 1/2-inch spacers together and do just that. And basically, a design like this has the effect of increasing the carb's flow capability. At a guess, I'd say that super sucker increased the flow from about 780 to maybe about 800 CFM. Now, all of that extra power has been had at a really, really low budget. Well, that's about it for this edition of PowerTec 10. Hopefully you've all taken the opportunity to subscribe and like and all that good stuff. For next episode, that will be episode 98, I believe, we are going to be doing a wheels deal on the Mustang. That's the installation of wider and, in this instance, larger diameter wheels plus tires on the Mustang, and we're using that just as a test bed. The principles apply to everything out there, and what they can do is not only improve the grip of your vehicle on the road, but also increase the acceleration rate and the braking capability. So don't miss that out. There's going to be stuff in this that you didn't see on any YouTube channel of any consequence. Thank you for watching.